Hi everyone, welcome back. If you want to support me, please just press like and subscribe. Looking at volume of rectangular prisms, we see them everywhere. There's tissue boxes just here beside me. Like a look at this room, it's a rectangular prism. And what's happening in each of these shapes, we need three numbers. So if I pointed to that point, say there, that one just there, I need that number, I need that number, and I need that number. So to get the volume of this, all you're doing is multiply that number by that number by that number. And by the way, if it's cubed, you're just multiplying by the same number times itself 3 times. Now, if you look at this one here, which is really common, the three of them are obviously very different. If I look at this room, it's obviously very different. If I picked up any shape, I can pick up my phone and look at it, or I can pick up a packet of tissue of wipes I've got here. The three numbers are all very different most of the time. Even the container I've got this standing on, the three numbers are very different. So all we're doing is looking for those three numbers. So if you look at the first question here, it's got a 5, it's got 2 9s, it's got 5 twice, it's got 4. But you can see it's got 3 different numbers. You can call that one A, you can call it B, you can call it C. It doesn't matter which one that you multiply, because you can multiply in any order. Because if this one turns out to be, for example, let's say I use the 5, I multiplied by the 9, and I multiplied by the 4. It doesn't matter which order I multiply them in. I can go 4 times 9 times 5 is the same as 5 times 9 times 4. So actually, if I was doing this and I didn't have a calculator, my brain will go 5 times 4 is 20. I'm actually going to write it down. 5 4s is 20. And they're going to multiply that by 9. And when they multiply that 5 4s, it turned out to be a nicer calculation. Now, if I went 9 10s, it'd be 90. But it's 9 20s, it's twice as big. So it's 180. Now, we're talking about volume. So on this one here is volume. Volume, if we're talking about centimetres, we're going to have centimetres and cube. So when it's volume, we talk about cubed. So volume is cubed. Next one here is surface area. So we're talking about area in this one. And area is going to be squared. Let's have a look at it again, see what's going on. There's a multiplication between the 2 and the A, between the A and the B, but that's a plus. Now, by the way, people can write these formulas in so many ways. Some people will write, you'll have a teacher who writes this as 2 with a bracket. You might have them writing length times the breadth times the height. And this will be length times the breadth, the length times, there's so many ways. Interesting, after 40 years of teaching it, I really like the ABC, and I'm finding with the students that are having a bit of trouble with the topic, the ABC seems to work better for them. So, I could have said here, there's A, I could have said there's B, and I could have said there's C. I could have put them in other orders, wouldn't have mattered. So let's have a look at what it says. It's a 2 times whatever A is, and A was in this case 5, and then B is 9, and then I put a plus, don't forget it's a plus. It's a 2 times whatever A is, which is 5, times the C this time, which is the 4. Actually, it's interesting that that looks very, very much like my tissue box. Just one of those flukes. Interesting, it's got that as 4. Yeah, that's interesting, but that's unrealistic. One of the things I don't like sometimes, if that's a 4, there's no way in the world that could be a 5. And that's what we talked about, it's not the scale. So when people create them on computers, often it's not the scale. It doesn't change the fact that we do the calculation the same. So I'll finish off the last bit, plus 2 times the B, which is 9, times the C, which is 4. Now, most of you just can put it in your calculator. This one up here, you can pick up your calculator and go 5 times 9 times 4. There might be some of you, depending where you are at school, where they'll be demanding that you do it by hand. So if you type that in your calculator and just go left to right and do exactly what it says, you end up getting 202. Now remember, we're talking about area. Area is, and if it's centimetres, we go centimetres per square. So that's straightforward. It's really easy when you know what the 3 numbers are. But you walk into the test and it's not clear which the 3 numbers are. So looking at this one here, there's so many ways. Oh, I want to talk about there's so many ways of explaining it. I talked a minute ago about if I had a point, if I can get 3 numbers coming to that point, that will tell me what's going on. Not thought about teaching that until fairly recently, even all these years of teaching. I've never said pick a point and get the 3 numbers. So I'm going to try that first. Let's go pick a point. Now, I wouldn't pick that one because there's only 1 number next to it. But I could pick that one, put a dot there maybe to make it really obvious. It's right next to it is a 3, and right next to it is a 7. So if I wanted to, I can go, I now know that A is 3 and B equals 7. Doesn't matter which way you say them, I'm just looking for those two numbers. Now here's the big part. When I was showing some students yesterday and the day before, if I drew that across there, some of my students went, oh, I've got it. If that's a 7, that's a 7. If that's a 7, that's a 7. And they could write there that that's 7 centimetres. So the three numbers that meet in the point, often you're given 2, but you're not given the third if you look at a lot of diagrams. That's one way of thinking. There's so many ways I've taught over the years. I think that's actually the best way I've seen. So now we've got A equals 3, B equals 7, but we've also got C equals 7. Now some people watching this will look at it and they just know, oh, there's lots of 7s. If there's more than 2 7s, we know we're using 7 twice. If there's more than 2 7s, we're using 7 twice. So if I look at a lot of diagrams, you'll see some numbers turn up more than others. Probably in nearly every question you'll ever look at, you'll see that they'll have them probably written 3 times, whereas this one's only written twice. So we're using 7 more often. So I'm going to write up here, we've got A equals 3, we've got B equals 7, and we've got C equals 7. All it means is that this part up the top here is actually a square. And probably doesn't matter if you don't think of it as a square, but that's just that's got the same numbers. So let's go for the volume. Volume, I can go A is 3 multiplied by B is 7 multiplied by C is 7. Now some of you probably don't need to watch the video anymore because you know what's happening, as long as you understood that. So then I can work out that's 21 by 7, or I can pick up my calculator and go 147. Remember, we're talking about centimetres, and we're talking about volume, so we're talking about a cube. The little 3 up there, going to keep nagging about the fact that we call that cubed. So surface area 2 times, that's a multiply. A is 3, there's another multiply. B is 7, there's an addition. 2 multiplied by A is 3, C is 7. So 2 multiplied by B is 7, by C is 7. And at that stage, really, you just put it in your calculator, unless again it says it's put by hand. Okay, so if you put that in the calculator left to right, you come up with 182 centimetres squared. And what it means is that if we get the area of that shape and the area of this shape, and we've thought of all the shapes that are on there, there's actually 6. In case you need to know this, there's that shape there, 1. There's the one opposite, which is the same size, 2. There's that one there, which is a little one. Opposite is another one, which is 4. I've done the big one, I've done that one, but I haven't done this long skinny one here. There's the 5th side, and if I turn it over, there's the 6th side. So all we're doing actually is going, get the 3 sides and double it. So if you have a look at this formula here, we get one of the sides, which is the area of a rectangle. We get another area of a rectangle, and we get another area of a rectangle. So they're the 3 different rectangles. And what do you do with each of them? We double them. Oh, I hope it helps. If you're enjoying it, I'll see you in another video in the future.